Chapter 11, Section 3 is entitled Equations in Two Variables. This is where we start graphing lines, and that's what Chapter 11 really is about in your book. Now, the stuff we add will help us graph all the other things, but right now, our primary concern is graphing lines. There's about 4 different ways we can graph lines. What we're doing today is called the table method. It's nothing more than plugging numbers into a table, coming up with points, and graphing the points, which really isn't too bad. But there are some forms that don't require quite as much work. There's slope-intercept form, point-slope form, and standard form. Now you're going to find by the time we finish graphing lines that there's one of these methods you're really going to like. And the other 3, while you'll be able to do them, you probably won't like them nearly as much. I can tell you for me, I graph everything pretty much with slope-intercept form because slope-intercept is the one that seems to be the easiest for me. But you may find by the time we finish graphing lines that you really like standard form. And the person sitting next to you might really like point-slope form. I don't really care which one you like and which one you don't like. That's not of concern to me. And as far as I'm concerned, when we're done with lines, you can pick whichever one you want to graph. I don't really care. But for these sections, you're going to have to do this method for scratch. Okay, so on the left side of the board over there, you can see I've set up a test problem, y equals 2x plus 3. And I described in simple terms the steps and what you're going to have to do. Step 1 says to set up a table and choose 5 x values. Now, what x values you choose are completely up to you. Most of the time, I'm going to pick -2, -1, 0, 1, and 2, just like I filled in the table already. In truth, you can pick any numbers you want for x. If you want to graph -1,000, -100, 0, 100, and 1,000, that's fine by me. Just remember, whatever numbers you pick, you have to be able to put on the graph, which is the one complicating factor. The only requirement I have, if you're going to pick different numbers, you have to have some negative, some positive, and 0. Other than that, you can pick whatever you want. All right. Step 2 then is to find the corresponding y values and fill in the table. Find the corresponding y values and fill into the table. So what that means is you're going to have to go through this equation here, y equals 2x plus 3, and you're going to have to change x into every one of these numbers and figure out y. So in other words, you're going to plug in those 5 numbers 5 different times and figure out what y is. So that's what we need to do right now. Okay. I'm going to start on the positive end and work backwards for no other reason that I can, and that I'm good with positive numbers much better than negative numbers, and that's going to help you, I would hope. Okay. So the first thing I'm going to do is I'm going to change x into 2. So that's 2 times 2, which is 4, plus 3, which is 7. Next thing I'm going to do, I'm going to change x into 1. So I've got 2 times 1, which is 2, plus 3, which is 5. Right. Third problem to solve. I'm going to change x into 0. 2 times 0 is 0, plus 3 is 3. Next thing I'm going to do is I'm going to change x into -1. 2 times -1 is -2, plus 3 is 1. And then finally -2. 2 times -2 is -4, plus 3 is -1. Now, as you can see, there is a pattern that developed in the table. As you can see, as I'm going this way, it's subtracting 2 each time. 7 minus 2 is 5, 5 minus 2 is 3, 3 minus 2 is 1, 1 minus 2 is -1. there's going to be a pattern every single time. So if you can figure out the pattern, that should save you from figuring out a few things. Now, it's not always going to be subtract 2. They could be adding 3. They could be adding 7, subtracting 9, subtracting a half, whatever. You have to figure out the pattern. Once you figure out the pattern, though, you should be able to fill in the rest of the table. That's why I started with positives. Because if you work out these positives and 0, you should hopefully be able to avoid plugging in the negatives altogether. Now, I know most of you are using a calculator, but some of you still will screw it up with negatives. So if we just skip the negatives altogether, we're better off. And that's what you'll see me do every time. Okay, step 3. I have to plot the points and connect. We're talking about graphing, so obviously we're going to be doing a lot of graphing here. I now have to go through and graph each set of points on the coordinate plane. So, 2, 7 has to be graphed. So that means I start at the origin and go right 2 and up 7. Put it down. One 5 means I go right 1, up 5, put a dot. 0, 3 means I don't go right or left, I just go up 3 and put a dot. -1, 1 means I go left 1, up 1, put a dot. Again, I'm restarting at the origin every single time. Crossbar. And then -2, -1 means I go left 2 and down 1 for my last dot. Just have to connect those then. And I would like you to, I'm not requiring you to, but I would like you to use a straight edge to connect these. And there you go. Now, again, I'm going to emphasize to you that what we're doing today is graphing lines. Right? So if you graph and you're getting a U, a V, a Z, a W, an N, a T, any weird thing, you're screwed up somewhere. Right? We're only graphing lines. If you get one point that's out of the flow and everything else seems to make a line, that's the tip off that that one point might be screwed up. Go back and check your calculation. Okay? Everything we're doing here today is lines. That's the only thing we're concerned about right now is a line. Okay. Let's go to example 1. Y equals 3x minus 2. Y equals 3x minus 2. Now, as you can see, I did make one slight change in this problem. I have the table going this way now instead of this way. Usually, I do have the table going this way. Okay, so let's start at the bottom here with 2, and I'll work up. So, first thing I have to do is change x into 2. So that's 3 times 2, which is 6, minus 2, which is 4. 1. 3 times 1 is 3, minus 2 is 1. 0. Change x to 0. 3 times 0 is 0, minus 2 is -2. And hopefully by now, you should see the pattern. As you can see, as we're going up, it's just subtracting 3. Which means this one has to be -5, and that one has to be -8. Again, yes, there's going to be a pattern every time.